Hello everybody, and welcome to another math video here at Sage of the Six Maths. Today we will be tackling a triangle problem here. The question is asking us to solve for this unknown length x between points D and C over here, okay? So the way we need to take a look at this problem is we have to take a look at two right-hand triangles, this smaller one inside here, and then this bigger one over here on the outside. Now, a key thing to note about this is these are not similar triangles, okay? And the reason why they're not similar triangles is because similar triangles would require these two hypotenuses, they need to be parallel, so they need to share this angle up here, but because both of these lines, with length 14 and 16, are coming from the same exact point, they don't share that same angle up on top here, so these triangles are not similar, so we can't use like a ratio to solve for this. So the first thing we need to do is we're going to solve this smaller inside triangle here. I'm going to call this length here AD, I'm going to call it y, okay? And we're going to solve for this y using Pythagorean theorem. So the way we're going to do that is we're going to go 10 squared plus y squared is equal to 14 squared. And then we're just going to rearrange this. We're going to move the 10 squared over to the other side, make it a negative. We'll go y squared is equal to 14 squared minus 10 squared. And then we're going to square root both sides, right? Just like that. And we'll have y is equal to square root of, one second, what's 14 squared here? That would be, here we go, 196. Right, so then we have y is equal to 196 minus 100 will give us the square root of 96. Okay, cool. So here we have square root of 96. Now here you can choose to leave it as the square root of 96, or you can convert it to a decimal point. It doesn't matter at this point since this is just an intermediate value, right? That's not what we're looking for. Our main goal is to find this x. Okay, so now we have the lengths here, so now we have to look at our bigger triangle, which is the one on the outside here, right? Once again, we're going to use Pythagorean theorem to solve for the length down here. Okay, so here we're going to have, now we're going to have 10 squared plus, now we need to figure out the length from A to C. And the length from A to C is actually going to be root 96 plus x, right? Because if I take this length here, AD, and add it to length DC, I will get the length of AC here. Okay, let's just go ahead and make this an equal sign here. So that is exactly what we're going to put into our Pythagorean theorem here. So I'm going to open up a bracket, and I'm going to go the square root of 96 plus x, and I'm going to square that whole thing, and that's equal to the hypotenuse squared, which is 16 squared. Okay, now just leave this as is for now. I'm going to do the same thing that I did over here. I'm going to take this 10 squared and I'm going to move it over to the other side. So I'm going to go root 96 plus x squared is equal to 16 squared minus 10 squared. Now, once again, we square root both sides, and here we'll have the square root of 96 plus x is equal to, here I have 16 squared, which is 256. So I have 256 minus 100. Okay, now I have the square root of 96 plus x. I'm just going to do this part here. And here I have the square root of 156. and then I just have to move this root 96 over to the other side by subtracting it from both sides, and I'll have x is equal to the square root of 156 minus the square root of 96. And if you guys go ahead and punch that into your calculator, you will get 2.69, or you can just call it a 2.7. Okay, so x will be equal to 2.7, and that will be your final answer there. Overall, not too bad. We just got to remember that these problems, they'll sometimes come up with, like when you're learning similar triangles, right? When you're doing ratios. So the thing to look out for is your rules for what's required for triangles to be similar. So make sure you check those before you tackle this problem using the similarity ratios, right? Yeah, that'll be about it. Thank you very much. Hope you enjoyed it, and we'll see you on the next one.